Okay, in lesson 4.7 here, we're going to talk about another type of function called a piecewise function. And these are kind of a little strange and a little bit odd looking, but they are just basically when we piece together functions together to make one full function. Okay, so this is what it says. A piecewise function is a function defined by two or more equations. Each piece of the function applies to a different part of its domain. So it has to do with the domain. And remember, domain would be our x values. Okay, as an example is shown below. Okay, so we've got the graph. If you go ahead and just take a look at the graph first, a couple things that you should notice is that the lines that are on there stop. Okay, and where they stop, we either have an open circle or a closed circle. Okay, which should make us think of inequalities. Which, oh hey, look, we've got some inequality symbols in here. Okay, so this function is both pieces together. Okay, so the first part of it is this equation right here, this line, which is x minus 2. Okay, we get that by figuring out our slope and our y-intercept. Okay, and we then define the domain with it. Okay, and so that is only when x is less than or equal to 0. We know it's equal to because of the closed. Okay, and then we can take a look at the next equation, which we then find the slope and the y-intercept of, okay, which we wrote there, 2x plus 1, okay, and we know that's when x is greater than 0, and it's not equal to because that circle is closed. Okay, now remember too, for this to be an actual function, both of these on the same line couldn't be filled in, okay, because then we would have two outputs for one input. Okay, so it says the expression x minus 2 represents the value of f of x when x is... Okay, we've actually already said that. Okay, so let's go ahead and take a look at one to start with. So this first one, we're not even going to look at the graph of it. We are literally just going to take the function and evaluate x values that they give to us. So we have to look at the inequality of the domain to help us decide which equation we're plugging in our x value to. Okay, so it says this, evaluate f of x when it equals, the first equation is 3x plus 1, and that's if x is less than 2. Okay, and x minus 5 if x is greater than or equal to 2. Okay, so when we look at letter A here, x equals 2, which means that it would fall in the second equation. Okay, so letter A, so we would do 2 minus 5. Okay, and that gets us 3. That's our first answer. It's that simple. Oh my goodness, 2 minus 5 is not 3, it's negative 3. Hang on. There we go. All right, now letter B. Okay. It says negative 1/3. Okay, so that means we would plug it into the first one because negative 1/3 is less than 2. Okay, so plug it into the equation. 3 times negative 1/3 plus 1. All right. 3 times negative 1/3 will be negative 1. Okay, plus 1 equals then 0. Okay, and 0 is our answer on that one. Okay? So that's how we use a piecewise function. Okay, so now let's go ahead and look at the graph. Okay, so we're going to graph this one. It says graph y equals negative x minus 4 if x is less than 0, and graph y equals x if x is greater than or equal to 0. Okay, so we're going to start with the top one. Okay, now the first thing that I'm always going to look for is where is my x values at? Okay, so this is less than 0. So if we look at the graph, that would be this whole section. So we're not going to go past our y-axis then. Okay, so just make sure that we've got that understood. Okay, so it's a good thing that our y-intercept is right there at that y-axis. Okay, now this will be an open circle because x is not equal to 0, it's less than 0. Okay, so open circle at this equation, so our y-intercept would be negative 4. So I got an open circle. I'm going to zoom in real quick because I want to make sure that we get this right. Okay, all right, now along with that, our slope then is it's not going to zoom out, is it? All right, there it goes. Our slope on this was negative 1, okay, which means that we are technically going up 1 and to the left. Now remember, we're only going to the left side here, so the rest of our graph only goes here. Okay, so we're finishing filling out that. I'm going to use my ruler here. The other thing that you got to make sure when you do the line and you've got an open circle, just make sure you attach it to the outside. Okay, because if you start going on inside, then it starts looking like it's a closed circle. Okay, all right, so that's the first part of the equation. Okay, the Second part here is y equals x when x is greater than or equal to 0. Okay, now the y-intercept on this would be 0, and it is a closed circle, and our slope is 1. So we're just going up like this. Okay, and this one actually, if you got a positive slope and a negative slope like this, sometimes they'll kind of look like an absolute value function that's been kind of broken up. Okay, so now it says find. That's how you graph it. Okay, now it says find the domain and range. Okay, so the domain, remember this is all of our x values, would be all real numbers. Okay, now our range are just our y values, which it looks like in this it would just be y would be greater than or equal to, not equal to, just greater than -4, right? Everything up above that would be our range. So everything up above here, all of this would be considered our range. But we stop right before we get to -4. So y is greater than -4. Okay, now this next part, we're going to go ahead and take a look at the graph and make the piecewise function from the graph. Okay, now I think my process with this would be to think about the range first and then do the equation that goes with it. Okay, so how we write these is f of x equals, and then we do our nice little fancy bracket. Okay, now the first part that I'm always going to go left to right across this, so I notice that this one over here on the left side is my first one, and that is only when x is less than 0. Okay, it's not equal to because it's an open circle. Now I can go ahead and write that equation out. Okay, the equation is going to be, we've already got the f of x equals part. Okay, my y-intercept is 3, so I know it's going to be plus 3. And it looks like my slope is just +1, right? Because this is a positive line. It's going up from left to right, and it's up 1 over 1, so it'd just be x plus 3. Okay. Now, the next part to this would be then when our domain is greater than or equal to 0. Okay. It looks like we've also got a positive slope going on here. Our y-intercept is -1, okay? And it looks like we're going up 2 over 1, which would mean that our slope is 2. So then we get 2x minus 1, okay? So like I said, that would be my process, is to figure out the domain part first so that we know how many equations we need to start with, and then go back and fill in our equations, okay? All right, so let's take a look here at this second one. Okay, we've got our, let's start with our f of x equals, and then our bracket. Okay, it looks like we've got 3 sections this time, so we should end up having 3 different domain areas. So starting on the left side here, it looks like when x is less than or equal to -2. Okay. Then we've got when x is between -2 and 1. So how we would write that is -2 is less than x, which is less than 1. Okay? And then our next section would be when x is greater than or equal to 1. Okay? All right, now we can go ahead and start filling in our equations. So for the first part, that's this left line. First thing that I notice is that this is a negative slope. Okay, now here's the next thing that I notice. I don't actually know what the y-intercept is. Okay, which means that I have to go back and fill in that part till I get to the y-intercept. So let's figure out what our slope is first. Our slope looks like it's going to be -1. So I've got -x. Okay, now I'm just going to go ahead on the graph here and fill it in till backwards, and it looks like our y-intercept would be at -2 then. Okay, so that's my first equation. Then my next one is just gonna, it's a horizontal line, which should make us think this is a special occasion. It should be y equals 2. So this is just literally 2. So no matter what, x values I plug in that section, my answer will be 2. Okay, and then if I take a look here at my next one, I also don't have my y-intercept here, so let's figure out our slope first. Our slope looks like it's up 2 over 1, which would be a slope of 2, and it's a positive direction. Okay, so then I need to just continue that slope. It looks like my y-intercept would then be at -3. Okay, and that's how I fill that out. Okay, so in this first section, we're just literally talking about how do we look at a piecewise function. Can we evaluate when necessary, so plugging in the x value to the right equation. Can you graph it? Can you define the domain and range? Okay, and then could you write the equation from the graph? All right, and that's the first part to this lesson.